Hello everyone, my name is Ashfaq Ahmed and I work in the field of bioinformatics and structural biology. Today we are going for an interesting tutorial and its title is Learn Exploratory Data Analysis and Machine Learning on Water Quality Dataset. What we will learn today, number one, we will learn how to perform exploratory data analysis on certain types of datasets. Also, we will learn the basics of machine learning and the application of machine learning on different datasets. So let's start. Okay, uh, before going into the tutorial side, I want to discuss just for 1 minute the dataset. The dataset we will use today is also called water potability dataset. It is in CSV format. It contains different variables or different columns. If you are new to the field, so for you, I will use the word the dataset contain different columns. Okay, so you can see now all are expanded. It contains a column of pH, hardness, solids, chloramine, sulfate, conductivity, organic carbon, and trihalomethanes, turbidity, and potability. If zero, that means that the water are not potable or not good for drinkable purposes. Okay, and if it is one, that shows that the water is drinkable or a human can use it. So this dataset contains almost 3,277 rows, and these are all the different columns. Remember, in terms of machine learning, I will call it features. So this dataset contains 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 feature. First, we will learn how we can explore the correlation or the different analysis of this dataset. And to that, we call EDA or exploratory data analysis. In the second part, we will use this portability as a target feature and we will train the whole data except portability. We will train the whole data into some certain model, then we will perform some preliminary analysis that which model is the best, and then finally we will use the same best model for prediction. So we will learn during the tutorial. So this was a brief introduction of the dataset which is present with me in my D directory, in directory of water dataset. So let's start. As usual, I will perform or I have prepared the Colab notebook for you. So I will perform this on the Colab notebook and later on you can use the same notebook for your analysis um, on different dataset if you want. So let's start. First of all, you have to enter this address here in your browser and you will see this kind of thing. The problem, okay, if your internet connection is not in a good condition and you are not seeing this well, then doesn't matter. I will keep this link in the description section of this video so you can take it from there. Okay, once you see this is my repository on GitHub. Now you click here and select trainings, h100/trainings. Once you select this training, you will see EDA and machine learning on water quality dataset. You need to just click here. Once you click here, now what you need to connect here. After some time, the notebook will be connected. Okay, this is my brief introduction, and this is the channel uh, cross link or just a cross citation, stand up citation. Okay, so first of all, we are going to start. We will import some necessary libraries. If you want to see the code which I'm using or this notebook is using, so you can click here, show code, and you can see it. Otherwise, you can hide it back, click here. Okay. Once it is connected, you just need to click it and run anyway. So it will import all the datasets, the libraries. Now it's the time to upload our dataset. So just run this cell. Now choose file. My dataset, the one I showed you, is present in this directory, water dataset, and it's this one, water potability.csv. It doesn't matter which kind of dataset you are using, because data is data, and the computer don't know what you are providing as a feed or as an input. So you can certainly provide different data sets. Okay. Uh, I would suggest to watch this video because in certain places the code may experience some problem and we will learn how to fix it. So if you just directly start performing this notebook, I'm afraid um, it may give an error. Okay. So now our dataset is loaded. You can confirm it from here. Just click here. You can see water potability.csv. Okay. Now we will load this data into the Panda data frame. But for that, you need to click here and see show code, and you can see this orange kind of or brown color this. So what you need, just click here and copy path. Now paste that path here. It will copy the path as well as the file name. Also, please take care, do not disturb these two upper dots. Okay, now click here, display basic information of the dataset. It depends what kind of dataset you are using. So once you click here, it will tell you that uh, in your dataset you have pH column, hardness, solids, chloramine, sulfates, and blah blah. We already discussed. And it will also show you first row or few rows of your dataset. Just it's showing you 4 or 5 rows. It will also tell you, is there any missing value? Like there is. You can see none in here. So these are the missing values in my datasets. Okay. Now, if you want to clear it, you can clear it. Okay. Let's say you want to save this descriptive statistic. Okay. Here, I came here, so sorry for that. Okay. Now we are going to handle the missing data. Like I showed you, some positions or some d- points are missing. You can see here in AN. That means that in this column or at this place, this data is not readable, or you can say missing. So how to treat that missing values? In this code, I write this code that if there is a missing data in a column or in a row, so just replace that data with the mean of the whole column. Okay, so it will perform this job. If you are using some another kind of data set, and if you are thinking that no, the mean is not going to handle or to solve this problem in my data set, so do not run this cell and just go there and manually just fix your data and then re-upload it. Okay, now I want to save some this descriptive data set, these description or these thing. If you want to save it, so it will be saved here. You can see descriptive stats underscore CSV. If you want to download, just click here and download. It will be downloaded into your download directory. Okay, now we will create various visualization to understand the distribution or the relationship of these features, or I would say these columns of the dataset. So first of all, we will see the relationship of the data on the histogram. So once you click here, it may take some 10 to 15 seconds and you will see this kind of thing. Now you can see this is about the pH, this is about the hardness, it's about the solids. It shows you the distribution of data. You can see that the one value in the portability column is on the lower side, almost, if I would say, it's almost 1300 values or 1300 entries. But on the other hand, almost 2000 entries of zero portability or negative portability, I would say. So that actually shows you the distribution of your data. Like if I teach you about the sulfate, so the sulfate in the whole data, this range is heavily populated. In more than 1000 entry, the sulfate entries are in this range. That is almost 350, I would say 330 to 340, like this. So this figure tells you the distribution of the data. The good thing is I kept in this notebook. Once you are seeing this figure, but simultaneously, the notebook has also saved this figure in a high quality figure. So you can click here and click the download, and you can have this figure in your computer. Now, we are going to visualize the same data or the same density map on the box plot. Okay, it will be kind of the same visualization, but the box plot. Now you are seeing the solid box plots, and other all others are very down, just like near to zero. The reason is that the solids data is on the higher side. You can see here solids is plus 10,000, 20,000, 30,000. So when the computer program just visualize this range, the other became very down the slope, not down the slope, but near to the x-axis. So this is the reason. But I kept all these visualization in this notebook because I don't know what kind of data you will use. So maybe in your case you don't like this figure. Maybe this figure is very much explanative in case of your data. So that's why also it will save the data, the water quality box plot PNG here. Now we are exploring some correlation between these different columns or between these different features. If the color is this brown, or it means 1. Actually, because why they are 1, this is a matrix, and the pH with pH. So it's the same value, so exactly similar or exactly correlated, you can say it is 1. And if the color is on this side, this range, dark blue, I would say, In that case, it means that these two columns or these two features are anti-correlated. Anti-correlated means, for example, if sulfate is 1, so this one, the solids will be higher. If solids are higher, sulfate will be lower. They are anti-correlated. But if solids are also higher and sulfates are also higher, so this seems a correlated trend. So this table exactly teach you these kind of things. Now we are going to generate pair plot. So you can see a correlation heat map picture from here. You can download it if you want. Now we are going to visualize the pair plot. What actually the pair plot is, I used hue as a portability. We call it as a hue. Hue means a kind of different color. So based on the portability, I colored the whole data and then I uh, manage it like you, if you want to show the readers or the reviewers the correlation of each two feature or the comparison of each two features. So this pair plot will do it, and it's a very heavy plot, so that's why it is taking time. So we will wait for, let's say, 10 seconds more and let's see what we are getting. Let me pause the session. I think it's taking a bit longer. Okay, welcome back. It took almost 1 minute. You can see here 1 minute. Okay, this is actually a very huge plot. You can see very huge plot. And now let me show you. This is the pair plot. Let me show you that. Okay, I'm going to download it. Obviously, it will be a high size image. The reason is that every image this notebook will generate will be on the higher pixel side, 600 dpi. So because I know most of you will use these figures in your thesis and publications, okay, let's say I'm going to visualize this figure, okay. So the orange color you are seeing means the portable, and the other color, I would say the bluish, that is not portable. You can see here portability 0, and 0 is the blue and 1 is it means portable. And you can see how much good DPI this figure has. Still, it is like you can see the lines clearly. It means if you print this image, it will be very neat and clean. Okay. Now, uh, if you are interested in comparison of only two, let's say I am interested in hardness versus conductivity, but the color should be based on portability. So you can say, you can click it here, it will generate this. Let's say you are interested in hardness and turbidity. Let's say turbidity. You will use the same spell which is present in the your data set. So you can change it manually. Okay. Also change this column here like conductivity to turbidity. And now, okay. Once again, if you want the hue to be based on, let's say, organic carbon. Okay. Organic carbon is not taking because we have set to put the hue from the start to the portability. So no, wait. Possibly this is an error, my spelling mistake. Okay, now this is the organic carbon, the hue. So if the organic carbon is 5, how many? If the organic carbon is 10, 15, 25. So that is up to you how you are using different things here. You can change the hue setting, you can change the turbidity setting, and you can change the portability setting. So that is up to you. Let me change it back because I know you will use this later. And okay, so if you want some more interpretation of the above results, so this is about the histogram, box plot, correlation matrix, pair plot, and scatter plot. Please read it. Okay, now we are coming to the part two, that how we will perform machine learning on this water quality data. Let me tell you just in 1 or 2 minutes what actually machine learning is or how it is working and how you can use it. So I will explain in a very brief way. Uh, okay, machine learning is a field and there are built-in models. If you don't know models, so these are kind of computational algorithms. So there are built-in computational algorithms and they have different names. The shortest way I can explain it to you. Their names include logistic regressions, random forest, gradient boosting, etc., etc. So I have included 6 models here in this analysis, and these are the most usable analysis if you read any research paper. So you will see that yes, these are the main uh, models people are using. Okay, so what machine learning do? Machine learning, this field contains the built-in models. We train we train these models on our data sets and then we check the performance of the training. We also call fitting. Some people call it training. Also, you can say model fitting or model training. These are the simple things. So how this training or fitting works? So let me teach you just in a 1 minute time. For example, this is the data and it contains almost 3000, okay, we will say 3000 lines, okay, just for ease of calculation. So we will select one of the target feature. This is our target feature. Let's say I'm selecting that portability is my target feature. Okay, now I will ask the model, all these models one by one, they to remember or memorize 80% of this data. So if you have 100 rows, actually I mean 80 rows. 80% means 80 rows. So in this case, we have some 3000 plus rows. So the computer will decide itself that I have to memorize 80% of the data. It also depends, you cannot, this is not hard and fast rule that you will use 80% of the data for the training. You can use 90%, you can use 70%. It depends on the model performance. Okay. And the remaining 20% of the data will be used as a test. So, for example, we ask the computer to memorize 80% of the data, and let's say this is our 80% data, this one. The computer will memorize all these columns, all this data. Now we will ask them to use this data, the remaining 20% data, and predict this column. Okay, the computer will predict it, this column. Then the real data the computer has, it has this column already, portability. When computer perform prediction, then we will ask the computer or we will ask the model like, okay, now tell me how much error you made. So the computer will compare its own prediction with this portability column or feature and will calculate and will tell me that I'm making this much error. So we will choose the model which gives us the lowest error, and that will be our best model. And I hope you got the point that what is the machine learning or how actually it is working. So now for machine learning, first of all, we will import the necessary libraries. I clicked it. Now I will run this cell if my data has some missing value. So I will handle it the same way like I discussed before that I use in the code to, if there is any missing value, so just keep the mean of the whole column. Okay. Now I'm testing or I'm calling these six models. It's also present logistic regression, random forest, these six model. I'm defining these models and then for each model I will train uh, some I will perform some training and test. Okay, let me wait. Iteration, yes, dictionary, yes, okay. In model fitting, you can say X is train and Y is also, Y is actually also train, and one is the prediction. Model predict that will be the 20%. Like I told you earlier on, normally it depends how people are handling or this thing. You can handle it with the 20%, 30%, 40%, whatever. So let's say run this. Okay. Now you can read this for logistic regression. The accuracy is 6.2, and these are the different values, how much accuracy achieved, how much score, how much precision, etc. If you are interested, otherwise if you are maybe in the field or a beginner in the field, then you have to look for the accuracy. Random forest 6.7, gradient boosting 6.5, svm 6.1, and Canon 6.2 and 6.5. Okay. Uh, One thing I will make changes in the weight name model fit this report accuracy. Okay. I will make here some change and you will see later on when you are using this notebook. So you can change the different options just like from 20 to 80 to 20% or 90% to 10% like I discussed to you above. Okay, now I want to visualize the model performance. In my case, the SVM, you can also read here, SVM, where it, the SVM got 6.9, 6.69, and I think it is the best model for this data. So we can also see it from these figures. This is the confusion matrix, like how much this model predicted the true labels and the predicted labels. So they just gives you the value of error Of course, there are some errors. 0.69, or if for simplicity, if we say that zero point 0.7 is the accuracy, so it means 70% this model predicts the accurate results, and 30% this model predicts the false result or the incorrect results. Also, this is called ROC curve, and this is called precision recall. I don't want to make this video bigger, so you can just read here, or you can read the literature. Okay, now we ask the program to select the best model. So the program select the best model with the SVM accuracy, this one. Now, if you are satisfied with the model accuracy, then we can click this one and it will calculate the important feature in the data. If you are not satisfied with this, then I would suggest to increase the data if possible. Also, tweak the training and testing options. For example, if you have used 80% of the data for training, now use 90% data for the training. And there are also other methods, but it will make this video more longer. So therefore, I'm trying to give you the basic stuffs here. Therefore, I'm not going there, but I hope the model will be pretty much okay. Okay. So based on this, the feature importance, sulfate is the important feature in the whole data, and then followed by the pH, solids, hardness, and trihalomethanes are the least significant feature in the data. Okay, now this is an important or step 3. We have performed some exploratory data analysis. We have also performed the machine learning part, and we found our best model, that is SVM. In our case, we got the accuracy rate of other models compared to the SVM, so SVM was the best. Now, let's say I have some data. This is the unknown data set. Let's say I have this data and I'm just removing this column. Okay, so this data contains pH, hardness, solids, and all the other except portability. I will save it. Okay, the data is similar but except portability. So I save it here in the unknown data prediction CSV. It's here. Now, what I'm trying to do, I will use the same model to predict the portability. So load the unknown dataset here. Here is the unknown dataset I have. Now you can see pH, hardness, solids, all each and everything is present except portability column. Now I will process it for the unknown values if there are. Now I'm going to make prediction, use the best model. So the 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 model has performed predictions. Now this is our prediction, like it says that all of your data, the portability is 0. Okay, if you want to save this prediction, let's say unknown data prediction.csv, it will be here some. Okay, let me change this name, because output file name prediction underscore one. We should see, yes, here. Now download it. Let me open this data. Now you can see the best model we got was SVM, and it predicted the portability column for us. So it depends which column you are using as a target, as I told you in the start. So in my case, I use this one. So that is why um, I predicted the portability. Okay. I hope you learned something new, and I have performed a similar kind of analysis already on the weather datasets. If you are interested to watch here, just click here. It will lead you to that video. Just last 1 minute request. I'm thankful to all of you that you are watching my videos from different corners of the world. And but I have one just kind of you can say complaint, I would say. My portal shows me that 70% people who are watching my videos are not my subscriber. So I'm just asking you one question that um, is I'm asking you for some dollars or for some money? No. So why not you are subscribing my channel if you are watching my videos? It doesn't matter if you don't subscribe, but at times I feel it that why people are watching my videos, but they are reluctant to subscribe. So just just like that, nothing else. So if the final request is if you are watching my videos, if you're liking my videos, if you're waiting for my videos, then or if you are learning something new from my videos, then it's a request to give me a subscription. And although, let me tell you that this channel is now monetized, and I don't like for monetization, 1,000 subscribers are required. I have almost 2,500, but still, for a kind of appreciation, that will be great if you subscribe to my channel. Thank you so much. Bye bye.